guys out on the same job sites with us, and we got all the respect in the world for what you guys do. First thing we want to do is thank you for what you do every day, and that's keeping us safe. This is, before we get started, I want to introduce my team. I'm Mike Powers. I work at our Safety and Training Center. This is Steve Crone. He works at our Safety and Training Center with us. He's one of our instructors. He teaches our linemen how to be linemen. Steve's also the guy that came up with the idea for this trailer and drew it all up and got with some of our safety advocates and some of our trainees. Ronnie Wells is one of our safety advocates and helped him build it. So we just kind of built this thing from scratch. Hope y'all like it. As I said, this is Ronnie Wells, guy in the tan colored shirt. Ronnie's one of our first responders that goes out whenever you guys go out on like a vehicle accident call, lights are out, that sort of thing. Ronnie's one of the first ones that shows up on the job site. And he's our first responder. He's a serviceman out of Midlothian area, out of the Richmond area. Ronnie. And then Richard Kirby. Richard's one of our safety specialists. He's a local guy. He's our safety specialist out of Midlothian that goes out and makes sure all our crews are working safely. Helps people, educate people with stuff like this. So, again, thank y'all for having us out here. Now, our electrical safety demonstration unit here, what we're going to do, we're backfeeding from your transformer over here. We're going to get, because of the voltage we've got in your transformer, we're going to get about 6,000 volts. It really is 6,000 volts on our primary here. We're going to put a meter on there and show it to you in a little bit. But what this is all about, at Dominion, safety is our #1 core value. And that doesn't mean, of course it means our safety for our employees, but it also means safety for guys like you, our first responders. We don't want anybody to get hurt around our product, working on our product, around our product, or certainly any of our customers get hurt with our product. So we've got this thing out here, and we hope to get videos. We shot some videos earlier. Hope to get those sort of things out, get it on the news, so as many people as possible can see the message and learn some of the hazards associated with electricity. Now you guys know that most people couldn't imagine today, living in today's society without electricity. All the conveniences it brings us. You flip the switch on, the lights come on. You turn the knob and your house gets cooler with the air conditioning and that sort of thing, day like today. But there are some inherent hazards associated with power lines, and we're going to talk to you about those. Times like after a storm, when the lines go down, you got low lines. We're going to talk a lot about that. Vehicle accident, where you guys, and this is where it really comes with you guys. You guys a lot of times get on the scene long before we do, and we want to teach you some of the hidden hazards maybe associated with a down power line, and keep you guys safe. So, all right, we're going to go ahead and get started. As you see, just to give you a little, like I say, when the red light comes on, we heated this thing up. Got about 6,000 or so volts on this thing. And you'll see the light over there. That's our watch light. That'll let you know that we've also got it powered up. It's got a little fuel switch. The red light just went off, so we killed the power to it. The first thing we're going to do, like I said, Steve is one of our instructors down at our training center. Now what we're going to do is we're getting ready to do something we teach all our linemen not to do. We're going to intentionally put a little ground on here to draw an arc, and that's just so we can show you what an electrical arc looks like. So, Mr. Wells, you ready? So that just shows you we're drawing an arc there. We've got this thing going. We've got our about 6,000 volts going to ground, and we're pulling it off, drawing an arc. And that's because we got a difference potential. You notice the crow up there? Everybody's seen a bird laying up on the wire, right? Yeah. Can anybody tell me why the bird can land up on the wire and he doesn't get hurt? Right. There's no path to ground. There's no difference of potential. We'll talk a lot about that. The difference of potential. You never want to become the path to ground. So the old bird, he can land up there on the wire, and there's no path to ground. But if he were to cross over that insulator there to the pole, he would become the path to ground. Well, that's one of the most important things to remember about this. We'll give you you guys saw the electrical arc a minute ago, but what would happen if we walked up to a down power line and were to reach out and touch it or get close to it? You would become that path to ground. So we're going to demonstrate that with a hot dog, and we use a hot dog because that's just something to kind of demonstrate. It's about the same consistency of the human body, and so we'll use a hot dog to demonstrate what happened if someone touched a down power line. Yeah, I was done. Anybody hungry? And I will say this, I mean, this is a very controlled environment here. We've got the kill switch. You guys saw Steve with the on and off switch, the on and off button here. The other thing, if you've ever seen like an electrical sine wave, you know, it's a sine wave up and down. Well, this thing starts at 0 and it's real quick because he's on and off with the kill switch. In the real world, on a real down power line, that thing may have well over 100 amps already on it, so it's higher up, and it gets to a higher fault current quicker. It'll be a much more intense arc, louder, more powerful. So this is just kind of a small scale, and this is the real deal, but it's kind of a small scale of what would happen in the real world. So we saw what would happen with the hot dog if you were to touch a power line. Our linemen work on our wooden poles. You guys probably seen at some point or another, you've seen our linemen climbing a pole, a wooden pole. There's a lot of places out there where our trucks just can't get to. So you see Ronnie's got rubber gloves and sleeves on. We're wearing fire retardant clothes. Each day before we go to work, and Richard will show you. Richard, you want to show them how you test your rubber gloves? Can anybody tell me why Richard's gloves might be two different colors? A yellow on the inside, black on the outside? Anybody got a guess?
See the color go through.
So you can see the color go through. That's exactly right. Little hairline cracks, and Richard's going to show you. We do a visual test and an air test. We pull the fingers apart, and that yellow on the inside, if he's looking at it from the outside, will help him see those little small cracks. And what he's doing is he's putting air pressure on there, putting it up to his ear. And even if there's the smallest little pinhole, he'll hear as it gets next to your ear, you can hear air seeping out of there. So, what happens if you do have a pinhole? Why is it so important that our linemen check those every day? You know, we depend our life depends on how well the shape of our gloves. So Steve's we're gonna poke a pinhole in a rubber glove, literally just a little stick pin. Stuck a pin in there. We're going to use that same ground probe that we had the hot dog on. Sometimes it takes a second or two to get to the spot, but this is to simulate. We use this for our trainees to show them why it's so important that they check their rubber gloves every day. Because we're all human, and sometimes we get busy and forget, lose focus on what we're doing. So we use this for our trainees to illustrate why it's so important to properly check their rubber gloves every day. Yeah, it's not good.
Did I put it in the right thing?
Oh, there you go. Yeah, sometimes it takes a second. It was literally just a little pinhole. But our guys, you know, you're up there, you're on the pole, you're standing on the pole, you reach up and you're working, and then you could become the pad to ground. Now, just this morning, we got a new piece of equipment for our live bind demonstration. The other station we were at this morning loaned us an old piece of fire hose. We've wet this thing down, and we want to demonstrate that even a fire hose, if it's wet, contaminated, will conduct electricity. So you may have to look or listen a little close. You'll see this thing start drawing an arc and smoking. See that again? So, this time of year, day like today, it's real nice outside. A lot of people are doing work in their yard. Anybody other than me got wives who got them busy doing all kinds of stuff? Significant others got them busy doing all kinds of stuff? Well, one of the things we want to teach people about, and you guys use aluminum ladders too, right? Most homeowners have an aluminum ladder. Well, any ladder, whether it's wood, fiberglass, certainly aluminum. Aluminum is a great conductor. As you can see, our primary, neutral, all our new stuff we put in is aluminum. So aluminum ladder is a great conductor. We saw what happened to the hot dog. Ronnie's going to demonstrate what would happen if you're carrying a ladder and you get into it. If you're carrying it upright around the power line, you get into the power line. That's a grounded plate down there. Ronnie's just going to draw an arc. But you remember the hot dog demonstration. If you're carrying a ladder on your shoulder, your body becomes the path to ground, just like that hot dog did. So we'll just show you how good a conductor an aluminum ladder is. Use this demonstration to help people understand why it's so important. Before you go out with that ladder, like we talked about our guys checking their rubber gloves, it's so important to look around and make sure if there's any overhead power lines in the area, where they are. And if you got to carry an aluminum ladder, you know, don't carry it extended, and get help carry it horizontally instead of vertically. like I say, you got that thing on your shoulder, it's easy to get it. And we unfortunately have cases like that where people get into our power lines with an aluminum ladder. That's where one of those times you guys would be out on the same location with us, trying to help the person, that unfortunate person. Now, how about a tree branch? A lot of times after a storm, when the winds pick up, you see tree branches hanging off the line like that. Just like that bird, we already talked about that, there's no difference of potential right now. And what could happen, you guys have all seen like a three-phase, what we call a three-phase line with cross arms and everything. But what could happen is you get a limb like this hanging off one of our outside lines, hanging off the primary. And if it's not touching anything, you can't see or anything. Show them one more time, Ronnie. That thing's up there, it's energized, it is conducting electricity. So if somebody were to come along and say, well, I'll just reach up, you don't hear anything or see anything, and try to knock that limb off the line, you could become the path to ground again, just like with the ladder. And we'll show you now. So here's with that limb with a little difference of potential. So you definitely wouldn't want to reach up and try to get that limb off the line. Or what should you do? Homeowner sees a limb on the line. Call the power company, call our helpline, and we'll get somebody out there that can, like Ronnie, one of our first responders, that can get safely get that limb off the line. All right, how about the old, it's almost Father's Day, right? People get the old Marlowe balloons, Valentine's Day, and all that, Happy Birthday, all that kind of stuff. Anybody ever seen Marlowe balloons up on the line? Well, we'll show you why they can cause us a little bit of problems. If we'd like for you to call us on that. Even though a Marlowe balloon will conduct electricity, we've taken the cutout door out, and you'll see in just a minute, kind of like that fire hose, you'll see this will actually conduct electricity through the Marlowe balloon, and you'll see the light come on at the other end. You'll probably see this thing sizzle. Sound a little bit like bacon cooking maybe or something. Light come on the other side. Alright, do you guys pull meters at your location? You go to a house fire, and believe it or not, some fire departments are still doing that. It's not a good idea. We'll give you an example of why. And I will tell you ahead of time, we've kind of rigged this meter base up to demonstrate. So it does have a short. We've created a short inside. But we'll show you in just a second what could happen. Inside that meter base, the only thing where the metal prongs are, the current flows through that meter. You got prongs on the top, prongs on the bottom, the line side and the load side, flows through it. If there's a short, the only thing that's insulating that from going to ground and creating a short is a little plastic, what we call a block. A little piece of plastic in there. If that thing breaks as you're going up after a house fire or something, you go to pull it, you could have a short. We'll show you what could happen there. It's going to make a little pop, some smoke. Like we said, most of the time our power lines are absolutely safe as long as they're up in the air. You don't see, don't give you any problem. They're just, you kind of forget about them, take them for granted. But there are times when they can become hazardous, and you guys see that. That's another location where you and the fire department and us lines up on the same location after a vehicle accident where a car hits a pole, and sometimes the wire can get down on top of the car. Well, we've got this little wagon for a couple of things. One, it can demonstrate like a car that can wire down on it. Or a crane, where we do have that happen. Unfortunately, we have cranes to get into the line. And so we've got this metal boom going down to and all this is a little landscape wing. Let's get that thing all the way on there. We'll get it all the way on there. We do have it sitting on, it's got rubber tires, it's sitting on a rubber blanket. So it's pretty well insulated. We're going to energize this wagon at full primary voltage. And Ron's going to put a voltmeter on there to show you. So we've got it energized now. So listen close, can y'all hear anything? See anything, smell anything? Well, you can't tell, but that wagon, just like a vehicle, is energized at full primary voltage. But you can't tell it. So if you were to walk up and try, somebody gets involved in a vehicle accident, as a first responder, to walk up, you could become that path to ground, just like we demonstrated with the hot dog and everything. So we've got a little model here. This guy look familiar? Anybody recognize this guy? That's Steve Kroon from the 70s. That's our little Steve doll. But anyway, if you were to walk up and you headed down, seriously, if you were to walk up and have a down power line on a car, you may not know that that car was energized. If you reach up and touch it, you become the path to ground.